issues behind launch.
What we're really doing, we're placing just mild steel galvanized rods into the ground. Just how we do that is, I will admit, somewhat futuristic. But the fact that the nails are in the ground is the end result, and that's what you've got to look at.
What's really important then is what's going on below the ground. A cross-section of a failing slope typically reveals a semicircular shaped block of soil that's slipping against an undisturbed area below. Where the two meet is called the slip surface. The idea behind soil nailing is to halt the movement by inserting nails perpendicular to the slip surface, anchoring the moving block of soil to this undisturbed area. Once the nails are in place, further soil movement places a load on the nails, causing resisting forces. These forces are developed by the friction and bearing between the soil and the nail, which produce tension, bending, and shear in the steel nail. The net result is equilibrium, and soil movement stops. Clearly, a site analysis by experienced personnel is needed to ensure that the soil nail launcher is a viable option for a site. The engineer or geologist will determine the likely cause of the failure, estimate its depth and width, and recommend a nail pattern. But designing with a soil nail launcher is necessarily a flexible process that may take a little getting used to.
You probably have some idea whether you need 30 nails versus 100 nails to stabilize some particular hunk of ground. But then once you get to the field, you're going to, they're not going to go in that way exactly. You're going to end up field adjusting them as necessary. You're going to shoot for approximately that number and approximately that grid, and that's probably going to give you the stability you need.
Working with 18-foot nails, repair is limited to slides 10 to 15 feet thick, and the length of the slope treatment is limited by the reach of the equipment. This ensures a nail penetration into stable soil of at least 3 feet. Typically, the nails are placed in a grid pattern with 3 to 4 foot spacings. Soil type, consistency, and moisture content must also be considered. The soil nail launcher performs well in granular clays with moderate obstruction. It gets more complicated with excessive groundwater or the presence of a high percentage of boulders. When a nail does encounter a boulder, because the energy is in the tip of the nail is either deflected, breaks the boulder, or stops. A lowboy transports the hydraulic excavator to the site, with a heavy-duty trailer carrying the gun, nails, and other equipment. The soil nail launcher does cover a lot of ground quickly. It's not unreasonable to expect to install 15 soil nails per hour.
It's a fairly quick and immediate repair type of a solution. You can be in and out within a matter of half a day. Whereas typically with our other type of repairs, this would have taken 3 to 4 days probably to repair a site like this.
The launcher can operate under a variety of seasonal conditions, and in the Colorado Rockies proved it could handle high altitude assignments, although the thin alpine air lengthened the cycle time between nail launchings. The articulated boom allows the launcher to install nails in various geometric patterns and to reach well above and below the road, minimizing or entirely eliminating access problems and right-of-way issues. With traffic control on site, the road can be left open with minimal delays. The equipment can easily move out of the way if necessary. Because the soil nail launcher minimizes site disturbance, observers were quick to notice the possible environmental benefits.
We might be able to use it in some areas that have, where we don't want to generate sediments in streams, where excavation would generate sediments. We might be able to stabilize some stream banks.
The soil nail launcher itself is a very small, compact piece of equipment, and so it would do very little, if any, type of disturbance to the area. When it launches the nail into the soil, it does not disturb that area right there around that item. So you cut off your nail, and there's no sign of it. So once you leave, there's no disturbance to that area.
The soil nail launcher did raise concerns about fire hazards from sparks from cutting nails in the field, and for the obvious noise level from the burst of compressed air. Both problems are being addressed in the next generation of the soil nail launcher. Small slope stability problems are a common ailment of roads on steep terrain and eat into annual maintenance budgets. But initial cost estimates hint that the soil nail launcher may offer a far more economical solution to these maintenance headaches. Assuming a 3-foot by 3-foot spacing and an estimated cost of $130 per installed nail, the estimated cost of reinforcing a slope is $14 per square foot. Traditional techniques like retaining walls cost anywhere from $15 to $60 per square foot. Keep in mind that these figures don't reflect the reduced environmental impacts of the soil nail launcher. The demonstrations convinced many observers that the soil nail launcher is a sound alternative to repairing shallow slope stability problems. This highly mobile piece of equipment, with a small crew, minimal right-of-way problems, and no costly excavation, offers road crews, engineers, and managers a whole new way of looking at repair work. But its ability to rapidly insert reinforcement elements into the soil had many observers thinking of other creative applications. For example, perforated nails could be installed as horizontal drains to reduce the number of landslides caused by seeping groundwater. Temporary fast-acting retaining walls and excavation support could be nailed quickly in place on larger projects. Facings could be attached to the ends of anchored nails. Soil nails could provide earth anchors and tiebacks. Or launch soil nails could rapidly add reinforcement to the materials behind existing retaining walls. These demonstrations were really a two-way street. Forestry and highway personnel learned about a new technology, while the developers of that technology listened carefully to their ideas for technical improvements and potential applications.
How deep can they shoot those nails?
It's equipment dependent. Now this video, Federal Highway has what we call our federal lands divisions. We have 3 federal offices, east, central, and western lands, and our folks who are in those offices basically perform like a highway department, but they work on, say, Indian Territory, Forest Service, Park Service, etc. So they have the same maintenance issues as you folks do on your projects. And the Forest Service asked them to come in for all the logging roads and so on, where they had slides. And they said that if this thing worked and got down deep enough across a slide plane, that they would take 5 of those devices and just have them shooting nails like crazy. Now, we have a soil nail program in Federal Highway, and it's for long-term soil nails. You just put the elements in, and that reinforces your soil. And you can also do the bioengineered, where you shoot live stakes and they take root and vegetation grows throughout that. The gun that you saw there is an air compressor, and that particular device was owned by that, or co-owned by that fellow Bernard Miles, and he's from Great Britain. So he came over and did this demo, and it didn't penetrate as deep as some of the people wanted. But in reality, penetration is directly proportional to how much compressed air they can put in their tank. So they've shot nails 40 feet into material. And the key here is all you got to do is get beyond the line. Now, one of the things in our soil nail manual, the Federal Highway Manual, is corrosion resistance. We want stuff to last for our lifetime and our grandkids. However, how much time would it take for one of those steel rods to corrode where it's ineffective? Essentially, it is reinforcing the soil. We're talking about maintenance. So that device could be very, very quick. And when they were talking about $14 per square foot for the cheapest retaining wall, they're talking about a time and labor intensive situation. I'm going to show you a picture of that. So in reality, the $130 he had per nail was reasonable. I got together with Bernard in January, and the device had gone to Korea for modification. They were building a silencer and increased pressure. And then apparently it's in UK now, and he's bringing it back here shortly. Let's look at some retaining structures, and I'm going to go through some of the more economical ones and the ones that you would tend to use for maintenance. Let's see, antenna, where is it? Okay, a retaining structure would increase resisting forces. It may be an expensive solution, and oftentimes it could be misused. And Barry, I think we got your head in the side there. No, it was my hand. But you did move very quickly. You are very obedient. I like that in a man. Right, Heather? Yes. Okay. Well, if, you know, concrete and reinforcing steel means you got to have somebody to design it. For maintenance, we're going to use engineering judgment. So we could put in concrete walls. Typically, what we're looking for is mass gravity structures, most likely. So the earth and rock buttress is actually a gravity wall that's very flexible. The crib walls, and I asked back here and decided that there isn't an economical crib wall. Most of them have gone out of business because it's a lot cheaper to do other type structures. The gabion walls, how many of you folks have ever worked with the gabion walls? Show of hands. Yeah. And I was overseas on assignment, and in a country that was relatively poor and had lots of labor, and lots of materials, but very little equipment. So we were building gabion retaining walls until I evaluated how much time they were spending and how much money. And we came up with an even more economical solution that I'll show you. So, well, you can put in piles and caissons. The piles, like Jim says, you can grow pile gardens. You got a 50-50 chance of it serving any good use, and it's going to be expensive. Caissons means you got to have an engineering design, and you need steel and concrete. A tie-back wall, you can take an H pile and you can tie it back, but the tie-back has to be designed. So the tie-back serves as an anchor. Tied piles is a combination of a cantilever and tie-back. Again, this is a design issue. Reinforced walls and slopes. We're doing a lot of this stuff, and currently, with today's prices on maintenance, you can build these walls for between $10 and $12 a square foot face, complete in place. And if you're doing it with staff forces, you can do it for about $8 a square foot. So let's take a quick look at the ones you might be more likely to use. Now, and Jim, I'm not picking on you. You're just a good one to pick on. But seriously, you showed a lot of those driven piles, and as Andy said, unless you go beyond the failure plane, and you have to get the toe embedded. I'm going to give you another rule of thumb. A cantilever structure should have a minimum of 1/3 of the height below ground. Okay? So, does that make sense? You got a 36-foot high structure, you might need to have 12 feet buried and 24 sticking up.
Is that 12 foot below that failure plane or 12 foot in the ground?
Well, it depends where the failure plane is. Because if this overburden is 15 feet thick and I drive it 12 feet below ground, right, we're talking about below the failure plane, but the failure plane may be lower. And the reason we're talking about the failure plane is just like a flagpole. If it's not embedded adequately, you're not going to be able to mobilize the strength. So it's just a rule of thumb. It actually works fairly well. When you get into longer, higher walls, your stresses are so high, it's probably not good to do that on a maintenance basis. Ben, could you just move the projector a little to the left? Usually, when I see these with transportation departments, there's usually a design that the state has done, and they keep it as a standard, and those would be built. Now, the same thing goes for the caisson. You have to bury it so that it develops its structure and it can adequately handle the bending moments with a reasonable factor of safety, and it's only going to resist those moments if this structure is embedded and below the failure plane into reasonably good material. The utility companies rarely ever design a utility pole. If you look at their standards, they'll say in clay, using a 12-inch timber pole, make sure that you're below so many feet. And if you're in sand, you have to go a little bit more because sand might be more loose, you know, and things like that. They have rules of thumb. Now, long, shallow failure. I've seen a lot in this part of the country. especially in colluvium. And you got a highway up here. The dashed line was where it was, and we got failure within the mass, but it was a relatively shallow failure because here was a rock line, and here was the overburdened soil, and here was a layer of weaker soil, so the shearing plane went through the weak layer. Now, if this costs quite a bit to repair, and it's so long, it's likely going to be very difficult to retain a long one. What we have done in Kentucky, we actually had to move the highway into the hill, and then we built a tieback wall that came down deep and supported the roadway. Does that make sense? Because you're basically burying a cantilever structure in the good material and supporting this. And if there's a tendency for the colluvium to keep moving, you might have to go 200 feet uphill and put in another tieback wall, this time just to support the material that might be moving. Okay? All right. We've got what they called a safety barrier on top of a retaining structure. And again, this thing looks inadequate because of why. Todd, can you see that all right?
Yeah,
Why isn't this adequate?
it's not into the rock.
It's not into the rock, and you want to develop some resistance, not just the gravity weight of this material. Okay? And this might be relatively thin, and you want to reuse it if you can, dry it up, and revegetate. And then it's analyzed like a cantilever structure retaining this material. In order to expedite a repair, about 22 years ago, a company by the name of Double Wall was created. And Double Wall built these, basically they're like large concrete masonry blocks that are, I think they come in 4, 8, 12-foot wide sections, and they're all precast concrete reinforced, and they have bins. And they just take these things and they stack them one on top of the other. They have a little shear key so that each one comes together. And it's just a gravity wall, and they fill the cells with gravel. And that's how they put a leveling pad just to make sure that all the blocks line up. But and this is just a function of design. As you go up, you have to widen. Because of cost, that too has sort of fallen by the wayside. I don't see a lot of gabions anymore, except in marine environments. And I'll show you why that is. And that was, Gene Geiger gave us a list of the 4 biggest slide problems in the state. And toe erosion was in the list of 4. So the gabion with a backing of filter fabric might be the best to use next to a river, a stream, maybe even a drainage ditch if you need a large ditch, or like a catchment ditch if you have a rock cut and you need to keep the falling rocks off the road. It could even be part of a berm, and basically it's rock placed in wire baskets, and the wire baskets are all tied together with galvanized wire. And when I was in private practice, I actually designed about 10 of those. The railroad up in Canada, they loved these things. They thought it was great. But whenever you're adjacent to water, you want to have erosion protection, filter fabric behind it, gravity wall to support the side. Now, here's another use that actually is still popular. I suggested the cobble boulder on top of a hypalon barrier when you line your ditches. My recommendation is line every ditch. Okay? Even if you have a drain below it, Jim had said, you know, cap the drain with a layer of clay. What we would do is just wrap it all, wrap the French drain in fabric, and then on this slope, keep the water out of the soil by lining it, line that ditch with a synthetic liner that is impermeable. And the reason they like to use these is in the case that riprap or shot rock may be more costly depending where you're at. With these baskets, they're about 1 foot in thickness, 1 foot in height, and they're all laced together. So if you have a steep drain slope and you have unreinforced blanket, it's possible that you need much larger particles, like 12 to 16-inch particles instead of 6-inch sizes. So the gabions allow you to use small ones. They could fill these with 3 to 6-inch size material. It's all laced in a basket, sits on the top. The only thing that's wrong with this picture is what? No fabric behind it.
You have much trouble with that back split on you?
Sorry?
You have much trouble with back split on you?
Well, actually, it depends on what you're in. And you would want to make sure that anything coming off here will flow in there. So you might want to, gravity might work fine, but if you need something here, you might even, I've seen where they put this in and then they planted vegetation everywhere.
We've done some asphalt like that, because there's sometimes that back so we kick that asphalt.
I used to recommend asphalt with continual reinforcement of a geosynthetic grid, and then it becomes a reinforced asphalt, but the performance still, the asphalted concrete still cracked. So I don't even recommend that anymore. Just one thing about, I know you and every other highway department in the United States, folks like to drive these little networks of piles. And don't get me wrong, it could be effective as long as you know where the shear plane is. And you got to do a little bit of engineering, a little more than just rules of thumb. That's the only problem. Now, what's wrong with this? They put nice little timber piles in there. What's wrong with this picture?
It's got too much mass to hold for one
Too
thing.
much mass to hold for one thing. Yep. That's exactly right. You would probably want to have something like this. They referred to this as anchored pile. Now check it out. Here's the shear plane. Here's that length. And that length is exactly 1/3 of the full height of that pile. Now, here it is, about 1/3. So you have to keep these things close enough, and you stagger the rolls because you take advantage of the soil that's in between there. Okay, and this is what happens if you don't take enough time. If those piles are sitting in the mass that's moving, and you may not know it until it moves again. So reinforced walls and slopes has become not only for maintenance. I would say the Park Service and Forest Service loves these things because you can blend them into the environment and actually not even see them in time. Now, and they do it more preferably without concrete, but they use a plastic grid, and they use, when they say an engineered geotextile, it's quality fabric that meets a certain standard. Metal strips for maintenance, you're not going to use that. For a design wall, we would. Now, we've seen people use signposts. They get a bunch of broken signposts that have been hit by trucks or kids or whatever, drunks. And they keep them in the maintenance yard, and then they'll bolt them together and stick them in the soil as a means of reinforcement. It's been done. I've seen it with guardrail as well. People using regular old chain link fence and concrete, reinforced concrete mesh. Andy showed you the concrete blocks tied together. Depending on the slope, the solution is if this is mostly all spoils from a slide, then Brett, have you been watching my back this whole time, or are you serious? Why didn't you tell me?
That's why I keep getting up and moving.
Oh, you should have said something. Too late. I know. Man,
Start over. He'll come back tomorrow if he starts.
We can start over.
we've been together for 2 days. You must be easy to get along with too.
Barry wants to stay on.
Okay, so what they do is they take that mass out, see that most of the slide is there. They're going to put in thin layers, and they're going to use fabric or geogrid, depending on what's available. And there's actually, Federal Highway has a little program that is a generic program on, you could use any fabric, grid, or whatever, and put it in there. But what I've seen with the Forest Service and some of the others that are just doing a maintenance wall, they just reinforce the material that came out, and they have a composite, and it's basically a gravity wall. And just like with the slides, you balance forces, well, you do the same thing with this thing. Okay, now sometimes we do these on very steep slopes. Again, the program will analyze anything like this, and obviously, and you mentioned it as well, you get to a point where building that drain is kind of awkward. Okay, when we talked about rolling material out, there's two types of grids, and depending on the height of the wall and what's being retained, the grids are either uniaxial, which means you want the strongest member to be from the back of the slope perpendicular to the front of the slope. The strongest member goes perpendicular. This, I think, is biaxial, which means it's the same strength in both directions, and they're just rolling it out. But I've seen the same thing where they'll come up with that spool and the arm, they'll tack it up here, and they'll just roll it down the slope. And that's what I did overseas. We just got rolls of fabric, and we had the same labor force, and we designed, I gave them a couple programs to work with, and they were able to put in synthetically reinforced slopes, and it became the most popular in the whole country. So these are pretty darn neat. You basically are coming up with layers. Now this wall is an engineered wall, but I want to show you. This is high density polymer. It has carbon black, about 2% carbon black, so that you have ultraviolet protection. But you want this stuff to last a long time, so notice that they're running this uniaxial material perpendicular to the face, and you can see how they do it. They roll it out, and they actually wrap it around, and then they backfill it and compact all the fill. In this case, there was concern about potential vandalism. If you're out in the woods, the hunters always have at least one knife, and they might want to take a souvenir. So what they did is they shotcreted the face. You can see some drain pipes. You still have to keep drainage, and that became a very good solution. And I'll show you a maintenance wall that was erected. They didn't worry so much about leveling pad and all that. They did it this way. And I was teaching a class. I was a guest lecturer at the Auburn University, and my daughter, who's now 19 years old, she and my wife had the day off, so they came to Auburn to watch my presentation. And I was so surprised because these were undergraduate students that we were talking to, and I gave an overview of geotechnical engineering, and I showed these structures. And then they had an open question answer, and to my surprise, my daughter asked, at the time she was like 10 or whatever, she asked more questions than the college students did. And the little bugger, when we got home, she wanted me to prove that this would work. So I said, I'll tell you what, we were going to the beach, and I said, I'll tell you what, I'll build one of these with you at the beach. So we went to the ocean, and she says, okay, I want to build the wall. And I said, well, what will happen if we build the sandcastle right where the water is? And she said, well, it's going to fall apart. The water's going to wash away. And I said, right. Okay. I said, I want you to get a bucket and go out and pick up as much seaweed off the beach as you can find. And when you fill the bucket, come back. And at first she thought I was sending her on a wild goose chase. Then she realized I was serious. And we took sand and we put it in layers, and I put the length facing perpendicular. I put seaweed, and then we put another layer of sand, and we got the thing like this high, and we had like 20 kids getting sand and seaweed after a while. They all wanted to see how high this thing could go. And obviously that wasn't an engineered material, but the concept really works well. And that's what they did. This is a maintenance type wall. You can see there was a scarp here. So a lot of maintenance yards and districts have these things, just rolls of this sitting in the yard. Okay. This was an experiment. Doug, am I in the way? Okay. It was an experiment. They took tires, sidewalls of tires, and they had some strips of steel with a little crossbar fabricated, and they hooked the sidewalls of the tires to that, and they built this wall. Basically, it's the same thing as my seaweed demo. And the front end loader came in and placed the material. Notice that the loader is not riding tracks over the material because you need to keep that in good shape. And so this is mostly that we covered mechanical stabilization. I'm going to give you 2 minutes here on chemical. And then we're going to look at a couple things on legal liability. Okay, chemical stabilization. I only put in the line. There are other chemicals, but environmental issues become a problem. Lime knocks out the plasticity. So you can mix it in thin layers. You gotta be able to wet the line down to keep the dust down. And then you just go back and forth, dragging and tilling this material, and then they compact it. What's the bottom line on all these various walls and slope repairs and so on?
Money.
Moolah. Okay. Money. So you might end up doing, Brian, 3 or 4 different solutions and estimate the cost and see which one works the best. The way this problem is set up, given we have a sliding wedge slope failure, so don't worry about a circular arc failure. Sliding wedge failure, that's given. You have these dimensions. If anybody has a little ruler, or just take a piece of paper and scale it off, compare that length to that one, or whatever you want to do. And you have a failed mass, and the failure plane is exactly where it's shown. And the question is a two-parter. Okay, will the proposed solution work? And seriously, please work alone on this. Will the proposed solution work? And if it doesn't, why not? And list 2 or more alternate solutions. Will the proposed solution work?
No. Going for a ride.
Are you sure?
Yeah, structure's not deep.
Okay, I could play the devil's advocate. The correct answer, since we are using engineering judgment, in looking at the size of this structure in comparison to the volume of the mass that's moving, that retaining structure, even if it were solid reinforced concrete, the only good it will serve is weight. And even if you do the gravity analysis and sum your forces about a central axis, by weight, geometrically, this is more likely to fail. And then part 2 of that, obviously, if the wall is above the failure plane, as some of you have said, it's going for a ride. Okay, number 2. If all don't yell at the same time, let me see. Heather, give us one answer for number 2. I want to see how many, Ben, if you can keep a list. Let's see how many solutions we've come up with.
You could extend the slope to go past the failure plane, like maybe a 4-to-1 or something.
I'm sorry, I actually
You could extend a flatter slope to go outside the failure plane.
Okay.
4-to-1.
Okay, extend a flat slope, but it's got to go beyond the failure plane. Good. Okay. Alex? Just one will do.
She got one of mine. My other one was a cantilever wall seated in the bedrock.
Cantilever wall sitting in the rock. Okay. Chris?
Counterburn or toe burn.
Okay. Ray? You got them all there? Todd, how about you, buddy?
They did both mine.
They did both. Oh, how many did more than 2? Why don't we just start with that? Show of hands. Okay. I want to see how many solutions. So you guys that raise your hand over here.
Benching.
Benching. Okay. And where would you bench and how?
Straight up from where the failure plane is there, just go straight out, just start benching. You bench coming out that way.
Start benching in here?
Yeah, you have to remove your failed material first.
Okay, if you removed all the spoils, which could very well be a solution, this, I bet no one else has a solution. What would you do when you put this material back?
Drainage and compact it.
Put in some drainage and compact it. What else might we do? Put a key in it. You're probably going to go below the failure plane because the failure plane probably has very soft soil in there and the highest water. So you want to go a little bit beyond that. How about filter fabric or reinforcement? Yeah, you would do that, and that may very well work. You'd have to crunch the numbers, but that may work. Who else has another solution that hasn't been mentioned?
Move the road.
Move the road.
Move the road. Okay. Another?
Lower the foundation of that retaining structure and lock it into rock.
Okay. What if a farmer has a big fence here and this is literally the end of the right-of-way? He's going to come into money. Good. Share a legal issue that you may have been involved with related to slopes. Okay, Jim.
I don't know how many people are aware of this, but we had an unfavorable decision issued by the Court of Claims for an accident which occurred in District 11 on State Route 7. I think the total claim was $225, but the court ruled that in the old days, if we didn't have notice that there was rock on the road, we didn't have constructive notice that that rock was there, then we weren't liable for someone who hit it. If we knew it was there, we were duty bound to go pick it up and get it off the road. The court ruled, and our defense was that we didn't have notification, and we had warning signs on rocket head. The court ruled that warning signs are not enough. That just by placing a falling rock sign, the department had constructive notice that they had a problem there, and that the department was negligent in not going further and erecting what I quote, fence barriers to protect traffic. We lost that case.
Okay. Did you guys produce an inventory.
After that,
Oh,
yes, you bet your ass we did, and we have a program that is installing fence barriers, just like the court issued that. We do
Okay.
the job every 3 years, $400,000.
Now, the solution is, seriously, a lot of states, and I was going to go through the appendices here, but you can look at it afterwards. The appendices to this manual have a lot of good tips on different solutions, estimating costs of various solutions. And in your manual, you've got, let's say you do have a rockfall area. And if you get 25 incidences in a year where rock is on the road, unless you have maintenance passing by that road 10 times a day or whatever, then what you should consider is either fixing the site, moving the road, but get up warning signs and maybe at a minimum tack up drapery, metal mesh on the face. And if a rock comes loose and it wants to fall down, it'll fall down to the bottom of the drape. You may have to run like a gabion basket or two there to collect what may fall, and that'll serve as a catchment area. Okay, the legal aspects, and this goes back some time. We have a course that I taught on legal aspects of geotechnical issues. But it's seriously, as long as you show evidence that you're doing reasonable and prudent work that's in accordance with the state of practice around the country, it may not even be the state of the art, which we always like to be on the cutting edge. But as long as you show reasonable and proven evidence that you've done something, you're okay. And obviously, if we have a lot of rockfall, we want to get out there and protect the public. And if we can't do it with our maintenance funds, then we have to do it with capital improvement funds, or ER funds. So, okay, the property owner's rights in response to invasion of property by sliding materials or interference with lateral support or names of public way. Now, the bottom line is if you get even a bulge coming off a side slope and that bulge rises on someone else's property, you got to do something to mitigate, but make sure you get a right of entry before you do that. Okay? Highway travelers have a right to be protected against injury, partially due to negligent construction or maintenance. And there was a major slide in another state, and the Associated Press ended up calling me for some reason, and they asked me if a new rock cut, which if we can do them vertically, we do, and just have a catchment area. If a new rock cut is built within the last 30 years, and an old rock cut where typically they random blasted and had rough faces, they said, should the new one be in better condition than the old one? And will people be more protected? And I did good because I didn't answer his question with the answer that he wanted. I said it really depends. So, and I gave him certain scenarios. And I gave him the example of I-40 that failed, and nothing else along 20 miles failed. And it was because we had a thunder cell and the material at this one site got supersaturated. Landslide encroachment onto adjacent property, I just mentioned that. Injury sustained from a landslide. Unfortunately, since I've been here in my last 18 years, there have been incidences where people were killed, and rightly so, they were compensated. But we've come a long way. Most of the damage is usually the claims of property damage. So you got to do a risk management or risk assessment, and even to the point of doing a cost-benefit analysis for different solutions. So the risk management is established records of inventory and inspection records. And you folks in maintenance, I think Andy mentioned this as well. If you don't have a line item for slides and rockfall, it's just in your regular operations, you should try and break that out as a separate item. Okay, after movement is noted, make regular inspections using forms and diaries. In the back of the book in the appendices, we have several pages with good boilerplate forms that you can use. And many states have adopted these forms as part of their inventory. And I believe that Ohio's inventory incorporates most of what we have here. Okay, document actions for corrective measures taken after movement. Of course, the bottom line here is document, document, document. And just reasonable and prudent. Lost the equipment here. Oh, there it is. Okay, after movement is noted, take photographs during each inspection. Erect warning signs. In some cases, along the Tennessee, North Carolina side, I've seen this, and they also, I know Washington State and Oregon State have actually, they've got flashing lights that are tied to motion on the face of certain slide sites. If there's motion on the slopes, it'll trigger flashing lights that are on the signs that say caution, rockfall area or slide area. The key is to have reasonable documentation. If you guys break out in your maintenance records line item for cleaning up debris or whatever, it proves that you are paying attention, you are recording that. And as much as it is to be reasonable and prudent, you need to break it out. So also have programs for corrective maintenance action as soon as possible to improve safety. Federal Highway, our strategic goals, national strategic goals, we have 6 of them, and one of them is national security and another one is safety. And then we have 4 others about protecting the environment and so on. Safety is right up there in the top of the list. So if a maintenance action doesn't provide safe travel, program a design project immediately. And that's where I said before, it may have to go on a capital improvement program. And most important, keep darn good records. Okay? Questions? Any question at all?